right, we're asked to expand x plus 4 to the fifth. Now, could you multiply this out? Yes, you could. Please know that that's not x to the fifth, 4 to the fifth, okay? That's a common mistake people make, because actually what this means is taking x plus 4 times itself 5 times. Now, yes, you could FOIL this out, but it would take a very, very long time, okay, more time than we want to take. You can use the binomial theorem to do the expansion for you. It does still take some work, but it is faster and takes less paper than foiling this out. Okay, you can also use Pascal's triangle, and in my next video I'll talk about how you can use Pascal's triangle, and then you can choose which one works best for you. Okay, so the binomial theorem says when I have a binomial, okay, a plus b to a power, we do the summations. Remember, this means we're adding together each term from 0 until we get to our power. So we start with n being 0, okay, j being 0, and go up until we get to our exponent we were using. I'm going to use this as an example up here. So x plus 4 to the fifth. If we wanted to expand that, we start by doing, okay, you're always going to use your power on top here, so 5, and you start with 0 here, all right? Then whatever your first term was, you take that, again, you start with your number minus whatever you have here. So in this case, 5 minus 0. The second term in your binomial, okay, we're going to take that times our second number to whatever number you have on the bottom this time, that's your power. Plus, then we go 1 over. Again, our number on top is 5, but the number on the bottom here goes up 1 to 1. Okay, so then we have x to the, instead of 5 minus 0, it's 5 minus 1. And then our 4, instead of to the 0 power, it's to the 1. So notice here, here, and here, we just went up 1. Plus, again, we start with a 5 here, but we go up 1 to 2 here, and all of those other spots. So we have 5 minus 2 for our exponent here, and 2 for our exponent on the 4, plus 5, 3 now. Okay, that gives us x to the 5 minus 3, and then 4 to the third. I'm going to run out of room here, darn it. Next would be 5 with a 4. Okay, so notice we're going up each time we're going up by 1. X to the 5 minus 4, and 4 to the fourth. Plus, oh darn it, I'm going to have to put this down here, which is really ugly, I apologize. We get to 5. When you get here, this is your last one. When the bottom number is the same as the top, that's your last one that you're going to do. And that would be x to the 5 minus 5, and then 4 to the fifth. Well, now we have to go through and simplify all of this. Hopefully you have your combination button on your calculator that, again, looks something like this, maybe a little different. If not, you would have to do the factorials. That would, again, be 5 factorial over 0 factorial, this 5 to the 0, over 5 minus 0 factorial, which can make this take a lot longer. So hopefully you have that button on your calculator. Okay, we're going to calculate each of these things. I'm going to start down here. So my first one was 5, 0. That turns out to be 1 if we simplify it. And then we have x to the 5 minus 0 would be 5. 4 to the 0 power, anything to the 0 power is just 1. Okay, so we have 1 times x to the fifth, plus 5 with 1 gives me just 5. X to the 5 minus 1 is the fourth power, and 4 to the first power is just 4. Plus 5 combination 2 gives me 10 when I calculate it. 5 minus 2 is 3 for my power on the x, and 4 squared is 16. Plus, the next term, 5 combination 3, also turns out to be 10. My x, the exponent 5 minus 3 is the exponent of 2, and then 4 to the third power is 64. Plus, 5 combination 4 brings me back to just 5 again. Here for my power in the x, 5 minus 4 is x to the first power. 4 to the fourth power gives me 256, so I'm multiplying by 256. Plus, here's my last one, 5. Combination 5 is just 1. X to the, this would 5 minus 5 would be the 0 power, and anything to the 0 power is just 1, and times 4 to the 5th, which is 1024. Okay, I'm going to simplify everything one more time because notice I have some things I need to multiply together. 1x to the 5th is just x to the 5th. Here 5 times 4 gives me 20 x to the 4th. 10 times 16 gives me 160 x to the 3rd. 10 times 64 gives me 640 x squared. And 5 times 256 gives me 1280 x to the first power. And then finally 1 times 1024 is just 1024. So we were able to expand that using the binomial theorem. And again, to be successful in that, you will need to be familiar with how to calculate these combinations. Okay, so if you have questions on that, contact your teacher or look up how to calculate those. Okay, we're going to do a few more to keep practicing because some things can happen. There's some things you want to watch for. Okay, so again, we're going to expand this. This time we're expanding to the 4th. Okay, you still start out with whatever your power is. In this case, it's the 4th power we're doing, and you start out with 0. You take your first term to your power, which again, this time it's a 4, minus the number on the bottom here is 0. You always start with that number minus 0. Then your second term, which is -1, you do want the negative there. That's going to be important. Okay, and that's going to start with this power here, 0. Okay, plus we go up 1 on the bottom here, and everywhere we have that number we go up 1. So we have 3x to the 4 minus 1 this time, and -1 to the first power. Then we have 4 combination 2, and we have 3x to the 4 minus 2 power, and -1 to the second power. Then we have 4 with 3. Okay, then we have, that gives us 3x to the 4 minus 3 power, and -1 to the third power. Plus, finally, once we meet here and have 4 and 4, we know this is our last term. That would be our 3x will be to the 4 minus 4, the 0 power, and our -1 will be to the 4th power. Okay, so notice how this term drops 1. Your first term drops an exponent of 1 each time, and your second term goes up a power each time. Let's calculate each of these. So 4 combination with 0 just gives me 1. Times, now one thing you want to be careful of, notice this is 3x to the 4th power. That means 3 to the 4th power, x to the 4th power. Since there's no addition in the middle there, we can just distribute that exponent. -1 to the 0 power is just 1. Here, 4 1 just gives me 4, and then I have 3x to the second power, or excuse me, that would be the third power. 4 minus 1 is 3, so that is 3 to the third power, okay, and x to the third power. On the end here, -1 to the first power is -1. Plus 4 with 2 gives me, yes, that gives me 6, and then times my 3x, this 4 minus 2 would be the second power, so that gives me 3 to the second power and x to the second power, and then -1 squared. Okay, we keep going. 4 combination 3 gives me just 4 once again. Here 4 minus 3 gives me 3x to the first power, so that's just 3 to the first power, x to the first power, and then -1 to the third power. Plus 4 with 4 gives me just 1. 4 minus 4 gives me an exponent of 0 here. Anything to the 0 power is just 1. And finally, I have times negative 1 to the 4th. Let's simplify a little bit more. Okay, so here I have 1 times 3 to the 4th is 81 x to the 4th, plus here I have 4 times 3 to the 3rd is 27 x to the 3rd times negative 1. Here I have 6 times 3 squared is 9, 3 squared is 9. Negative 1 squared is positive 1. Here I have 4 times 3 times x, negative 1 to the 3rd power comes out as negative 1. And finally on the end here, negative 1 to the 4th power is positive 1. So I have 1 times positive 1 there. Let's go ahead and finalize this by multiplying those last things out. So I have 81x to the 4th. Here I have 4 times 27 times negative 1. That's why it was so important we put the negative 1 in our exponent, so we didn't leave out our negatives there. That gives me negative 108x to the 3rd. Plus, here we have 6 times 9 times 1, which just leaves me with 54 and an x squared. Here we have 4 times 3 times negative 1 is a negative 12x. And finally on the end there, 1 times 1 is just 1. So that would be our full expansion of this problem. Okay, I'm going to go through one more. This one adds one more thing. We have variables, and the variables have exponents on them. We're going to expand this to the 3rd. Okay, so we start, again, with, since we're going to the 3rd power, we start with a 3 here and 0 here. Then we take our first term in our binomial, 2v, and we subtract these, the 3 minus 0. The second term in our binomial, 2y to the 3rd, we would take that to the 0. Plus, we go up 1 on the bottom there, so then we have x squared to the 3 minus 1, and 2y to the 3rd to the 1st, okay? Plus 3 taken 2 at a time. Then we have our x squared would be to the 3 minus 2 power, and 2y to the 3rd would be squared. Notice these numbers all match. And here's our last one. We know it's our last one because we have the same number in top and bottom. We have our x squared to the 3 minus 3, and our 2y to the 3rd is going to be to the 3rd power. Okay, let's do our combinations here. 3 taken 0 just leaves me with 1. This would be x squared to the 3rd power, and 2y to the 3rd, anything to the 0 power is just 1. Okay, here, 3 taken 1 at a time is just 3 times, so give me x squared to the 2nd power when I do 3 minus 1, times 2y to the 3rd to the 1st power is just 2y to the 3rd. Plus, here, 3 taken 2 at a time is also 3. Then we have our x squared is going to be to the 1st power. 3 minus 2 is 1, so we just get x squared. And then 2y to the 3rd squared. Plus, 3 taken 3 at a time is just 1. X squared to the 0 power. 3 minus 3 is 0. And then times 2y to the 3rd to the 3rd. Okay, let's simplify a bit more. So here we have 1 times x squared to the 3rd. You multiply exponents here. So 2 times 3 would give me a 6th power. Plus 3 times, again, 2 times 2 gives me x to the 4th. Okay, and then times 2y to the 3rd. Plus 3 times, here I have just a plain old x squared. Here, this squared has to go to both the 2 and the y to the 3rd. So that's going to give me 2 squared, which is 4, and y to the 3rd squared, you multiply the exponents, so that gives me y to the 6th. Plus 1 times, and again here, because there's no addition here, it's multiplication, I just distribute that exponent. So 2 to the 3rd power gives me 8, and y to the 3rd to the third, multiply your exponents, you get y to the 9th. Let's finish out. 1 times x to the 6th is just x to the 6th. 3 times 2 gives me a 6 here, and then I have an x to the 4th and a y to the 3rd. Plus 3 times 4, I multiply the numbers, and then I have an x squared and a y to the 6th. Finally, on the end, 1 times 8 gives me 8, y to the 9th. Now, if I had had a subtraction sign here, my signs would alternate like they did on the last one. I'd have a positive, negative. Okay, so you'll want to watch for that. Anytime you have subtraction in the middle there, you should have some negatives in there, and they actually should alternate. You should start positive, negative, just to double check your work. But this is what our expansion would look like. X to the 6th plus 6x to the 4th, y to the 3rd, plus 12x squared y to the 6th, plus 8y to the 9th.